So for this integral, x values go from 1 to 4, and y values go from 1 to x, giving us region of integration, x from 0 to 4, y from 1 to x. And now here's a picture of our region of integration. We're integrating the function 2x plus y. Well, that function 2x plus y, if we want to graph that function, we're going to have to graph it in an x, y, z set of coordinates. And we, by now, should recognize that as a plane. So we can sketch that plane, and we're going to sketch it relative to this region. Okay? Now the plane itself is has z-intercept. Find a color I haven't used. Got a little piece of yellow here. Okay, the z-intercept is 0, right? When x is 0 and y is 0, z is 0. Okay? In the yz plane, x is 0, so you have y equals z, right? So in the yz plane, you have this. So that's in the plane above y, okay? In the xz plane, we have y equals, z equals 2x, right? So, find another color. In this plane, z equals 2x. So this is z equals y in the yz plane, and z equals 2x in the xz plane. Okay? So you have a plane that's increasing this way and this way. So it's like you have in the yz direction, you have this slope. In the xz direction, you have this slope, and you have a plane that's moving away from the origin in the first quadrant, like so. I'm not going to attempt to shade in and sketch that plane, but it gives you, this gives you sort of a picture. The region of the xy plane that corresponds to this integral is just what we pictured here. And we can see that it has vertices at 4, 4, 4, 1, and 1, 1. Okay? So, 1, 1, let's just say x equals 1 here, y equals 1 here, 1, 1 would be here. Okay, 4, 1, well, you come out 4 times that far, and let's say here's your point, 4, 1. In the xy plane, right? Now that we're in 3 dimensions, we'll call this point 4, 1, 0. We'll call this point, that's not a good place to label, it's 1, 1, 0, and I'll label it later when I figure out where is a good place to label it. And then we've also got 4, 4. Zero. So that this region here, that I'll again shade in red, now looks like this. Okay? Now at the point 1, 1, 0, the function f of xy is our 2x plus y function. Maybe should have written that there before, but I think it was implicit. Okay? Our f of xy equals 2x plus y function is what we're attempting to look at. Okay? And here it is in the yz plane. Here it is in the xz plane. Again, we see a plane kind of coming out like this. So what's the value at the point 1, 1, 0? Well, at the point where x and y are both 1. Well, if x and y are both 1, then 2x plus y is 3. Okay? Now that corresponds to the idea that if you go over 1 unit in the y direction with the z equals y line, z is going to equal 1, right? So you come over 1 unit in the y direction and z is going to, you're going to add 1 to the z coordinate, right? But also you come out 1 unit in the x direction and you're going to have a z equals 3 here, right? Or z equals 2 here. Okay? So if you go 1 unit here, you go up to 1. Then you come out 1 unit from here, you go up another 2 because of this. And I'm being a little vague, but that's, you know, you want to think about that. And you get z equals 3. Okay? So, like you come out 1 here, then you come out in this direction and you go up 2 more here, and now you're at this point here. So this is the point 1, 1, 3. Now I'm going to label that and hope that I don't have to erase it later. My best guess about a good place to label it is here. I should have left myself more room. That's on the graph of f of xy. Now above the point 4, 1, 0, you're much higher. X is 4, 2 times that is 8, y is 1, so you're up 17. Okay, so here above this point, and as I said, I didn't anticipate the labeling well, but above here, you have the point 4, 1, 17. Okay? And at 4, 4, 0, you're going to be up at 4, 4, 20. Okay? Because 4 here and 4 here. 4, 4, 20. Wait a minute. It's not 17. I don't know where I got 17. It's 9. So here, it's going to be 4, 4, 12. So above here, you have the point 4, 4, 12. Okay? Now, let's picture that again and give myself a little room. Without all the labeling and without all the explanation and without drawing these traces in the x, y, and the y, z, and, well, let's say the zx and the zy planes, okay? The picture is going to look much like this. At this point, and this point, so here's our region. Here's a right angle, okay? Above this point, we come up about this far. Above this point, we come up quite a bit further. And above this point, we come up even further. Okay? So now we have something like this, that represents a triangle that's coming out of the board at us as we go up. Okay? And we're looking then I'm going to want to shade this a little bit to make it look a little better. Okay? But we've got a solid defined here. Where this is the front face, and these lines will be dotted because they're not visible because of this being in front. So I make these lines, well, kind of hard to make them dotted. Chalk tends to smear. Let's see what I can do. A little cleaning fluid. It's too much. And then I'll have a dotted line from here to here. And a dotted line from here to here. Does that make sense? Okay? Well, our integral gives us the volume of this region. Okay?